Now let's start with chapter 2, that is class as basis of all computations. The first topic we are studying is object. An object can be thought of as an entity having specific identity, specific characteristics and specific behavior. For example, if this orange is an object, so it has some characteristics. It is spherical, it is orange in color, it has some behavior, it is citrus, it is sweet, it is sour, and it has some identity that it is a fruit. Its name is orange. So it has some identity, it has some characteristics, it has some behavior. So this is an object. Okay. Object characteristics, characteristics or state. Objects characteristics or states is maintained by data items and behavior is controlled by methods. For example, if orange is an object, it would have some data items that are, for example, variables, constants. So these will mention the characteristics of the state it is in, and the behavior, what it will do, will be inside a method. For example, if B star is a method of orange object, then the B star method will give the behavior to object of being sour. The next topic is properties of an object. Object encapsulate state and behavior. The state of an object is represented through values, attributes of its characteristics at given point of time. For example, a switch has two states, off and on. If switch is an object, for example, and it has a variable state. So state has two values. State is on. If state is on, the state of switch will be this. If state equals to off, then state of switch object will be this. Other properties of an object are abstraction and encapsulation. Abstraction is object helps in abstraction, and encapsulation as well. Encapsulation easily because an object encapsulates a lot of data inside it, and it encapsulates a class inside it. Then comes a class. What is a class? A class is a blueprint of objects that have common structure and common behavior. For example, fruits are orange was and object. So that object's class is fruit. Now because fruit is a blueprint of objects that have common structure and common behavior. There are some similarities between orange and apple because there are fruits. So fruit is a class. So fruit is the blueprint representing those objects. Class can be compared to a cookie cutter because a cookie cutter creates many cookies, and if those cookies are objects, so class is a cookie cutter because it creates many cookies. Now class is a named software representation for abstraction. Abstraction is relative to the purpose of the user, therefore classes are created for abstraction. For each abstraction there has to be a class. A class implements characteristics through data members and behaviors through method. The same thing we studied for object, a class implements characteristics through data items and behavior through method. Class is basis of all computations. Everything Java has to exist inside a class, as Java is a pure OOP language. Java is a OP language. As Java is a pure OOP language, all functionalities in Java revolve around classes. Therefore, if we have to even create a variable, there it requires a class. All programs consist of objects that interact with each other using methods. Without classes, there are no objects, and without objects, there are no computations will take place. Therefore, class forms the basis of all computations in Java. As Java is a pure OOP language, that is object-oriented programming. Java is a pure object-oriented programming. Therefore, everything in the program has to exist inside class. Okay, all the data members, all the methods have to exist inside class, and these classes create objects. Without objects there can be no computations, and if there are no computations, what is the need for a program? So we make a program to do some computations, and that computations cannot be done without objects, and that objects cannot be created without classes. So class becomes the basis of all computations. Now, how to declare a class? First, access specifiers. What are the access specifiers? We'll learn in deep later on, but for now, access specifiers are public, private, protected, and if we leave space, it is default. So there are 4 different types of access specifiers. Then there is keyword class, and there is the class name. Class name, we have studied the rules for giving identifiers. That rules are followed giving name for class as well. So this is class declaration. Here we write this, and then inside the class declaration there comes the class body. Static and instance variables. So this is an important topic. There are 2 types of variables in class: static variables and instance variables. Static variables are also known as class variables. A data member that is declared once for all objects or for all class. There is a class. So there are many objects. There are many objects. So if there is a static or class variable, it will be declared for all objects at once. So if there is change made in this object, the change will be impacted in this object as well. This variable is shared by all. But let's come to instance variable. Instance variable is created for every object of the class. This object will have an instance variable, this will have an instance variable, this will have an instance variable. If any change done to object 1, instance variable of object 1, instance variable of object 5 will not be impacted. But if a static variable of object 1 is impacted, static variable of object 5 will also be impacted. Now, topic 2.7, creating objects. First, we write class name. For example, class is fruit, so fruit. Object name orange equals to new fruit. We learn about constructors ahead. Each object declaration has 3 parts: the declaration, the code on the left of equal to. So this is the declaration part, class name and the object name. Then comes instantiation, that is new is an operator that allocates memory. New is a keyword that allocates memory to something. For example, new here will allocate a memory space to the object orange. Now initialization, the constructor initializes the object. This constructor initializes the object. So we are doing these 3 things in one statement. What are constructors? We'll learn ahead. Using objects, we can do 2 things with an object. We can manipulate or inspect its variables. We can call its methods. For example, object dot method. We can call a method like this to do something, or we can manipulate object dot variable plus plus. So that variable will be increased. To refer to a variable of an object name dot variable name. For example, rect3 dot width, rect2 dot length. To call a method, object name dot method name and parameters. For example, rect3 dot area 150. This was chapter 2. Very small, very easy, nothing to be difficult. If you are finding it difficult, read this, watch this video again, question yourself. The notes are available for download. Download it, study it, revise it again and again and again and again. We have to score at least 90% and we have to at least aim for 100%. 100% should be our goal and we have to achieve it. This was the end of chapter 2. We'll continue with chapter 3. Thank you.